Hey guys, everything going well? Let's take a look at number 79, word search. Given a 2D board and word, find if the word exists in the grid. The word can be constructed from letters of sequentially adjacent cell, where adjacent cells are those horizontally, vertically neighboring. The same letter cell may not be used for more than once. The same letter cell may not be used for more than once, so B, C, C, F, B is not okay, right? Yeah. But if IBFCC is okay. Okay. Okay, if we are given a word A, B, C, C, D, A, B, C, 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 E, D. Okay, true. S, E, E, S, no. S, E, no. S, E, E, okay. So I think this is a typical backtracking problem. We'll just search through all the possible board and find if it is possibly the next digit. We will use a temporary array to keep track of the current word. Like when we are searching A, B, C, C, E, D, there's an empty array. First we're going to search A. We loop to here. Okay, it's A. And then, okay, let's say the next one is if it is B. Yeah, it's B. Then C. Yeah, E. Okay, S. No, C. This is not C, so we will skip it, and then we go to this one, C. It is, so we pushed it, and now we're going to find E. S, no, E. Okay, now I find D. E, not D, D. Okay, it matches our word. It matches our word, and then we would say it is true, right? The one problem is that we cannot use the word more than once. The letter more than once, so we need to keep track of whether the letter is already used or not. Okay, so I will first map to keep track of the usage is const is used. I'll say it should be board map. It should be a row, and it should be row map. It should be a 0, so it's false. Okay, let's say it's a false. It is not used. Now we need to we not used to we need to create the walk method, right? Let's say cost walk, and the first we target the const target. We will split the string into set, new set, word split, and const current is new set array. Oh, okay, we use array, it will be better. The current is empty, right? So it's okay. Now we start walk, and finally, if nothing happened, we return false. And when we walk, we will, for each walk, we're actually walking to specific target, right? So it should be I and j, which is the coordinate. And for the start, we walk from 0, 0, 0 row, 0 column. So for each walk, what we do, we will check if it is the one of the word we needed, target needed, right? Check if the letter is what we want. Yeah, so if board ij is equal to target 0, if the first letter, then we should push the target 0, and then target should unshift, right? I think this should be shift, not unshift. This should be good. We just push the target into the current. Like we met A, Now current would be A. The next one would be, we are going to search B, C, E, D. So when this is possible, now we will try to walk, continue the next walk in 4 directions. Okay, first I forgot if to use if it is used or not. The ending condition, if it is already used, we will just return, right? If, in the walk method, I cannot just return true for this exist function, so I'll create if let is found is false, we return is found. Okay, if we will check here when we push it, if target length, if it's empty, is found equals true, we will return true. It's not last but false. Okay. Ending condition. If it's not ending, we just continue the walk in 4 directions. Okay, so our will, the 4 direction would be so how can we continue walking 4 directions? The first, I think I need to define the directions. Okay, I'll say the directions would be, I'll say the const directions would be directions. First, we go down. This is down. Oh wait. X is a row, doesn't change. Y goes to the next one. So, oh, my bad. It's right. -1 would be left. 1, 0, down. -1, 0, up. And say, I have, this is 4 directions. Okay, for let direction of directions const new I new j equals to I plus direction 0, j plus direction 1. This is our new coordinate in a now we walk there. We try to walk there. Return, if it is used, return false, right? And if I smaller than 0 or I is bigger than board length -1, return false. J smaller than 1 or j smaller than board length. Return false, right? It's just out of bound. It is out of the board. Out of board, and this is used, return false, and then finally we made something, return true. Okay, so for this walk we return true. It is not true, I think. They should be depending on the next one. So, oh yeah, this is true. And now for each direction we have this new coordinate, and then we need to walk it. If one of them succeed, we don't need to do it again, right? So let is if we found, and then we return. Oh yeah, here. If we walk to new coordinate, new j, so which means find the match. If that's the case, we will just return true. Yeah, we return true, and return true, and it is done. And return true, and the walk would be we return. So walk, the recursion here will all be terminated. So return true, and how can I set is found? Oh, is found true. This is true. Okay, this found is also true. We return. Cool. Or we can say we can just break. Break is maybe better to understand, because when we don't check, actually we only, when we found this found here, we return true, right? So the previous one would be break. Oh, but if I've checked here, so okay, I need to return true. Oh, anyway, so now we checked it. I think we already done. But no, we forgot to update the is used, right? When we put it, we check, we push the target into here. We will update the is used. Is used I and j equals true. Targeting found. For that, everything found. We walk, but if there's still nothing found, then this is not. We're not able to push this. This is not a possible solution, right? So we need to backtrack. Tracking. We will revert it to the target push. It's not push right now. It should be on shift. Target. It should be, let's say, A, B, C, C, E, D. We got A, we got B. Now, so we should be pop. We pop it and move to unshift. Okay, that is used to false, so we cannot use it again. I think I have a little confidence of this. Let's try. Oops. Unexpected token. Was 0. Oh, my bad. Let's submit. Oh, shit. We got the wrong answer. A, B, B, A. There's left, right? Yeah. Ah, my bad. Oh, yeah. So the walk is not good because we have all the possibilities we can walk. Okay, for the start point would be any point. 0 I board.length I plus plus. For let j is smaller than board 0.length j plus plus walk I j. And let's say if already walked, then I need to break. All right. Oh, for this 4 here, I can just say I return true. And finally, we return false. Yeah, let's copy the input here. Submit. Oh, it's still we got an wrong answer. For this A, we got A. Okay, let's say it's true. So if it is true, we return false. Let's cancel lock walk ij. Walk 0, 0, 0, 1, 0, 2, no. And then we say 0, 0. It's used, right? So we go to 1, 1. No. So it's minus 1, 1. No. And now we know. So 0 is not. Cancel lock pass. Oh no, pass not here. Oh, finally, I here actually return false. Right? We only say and I say lock pass. Okay, walk 0, 0. Okay, pass. Walk 0, 1. Pass. And now we have another A. 0, 2. And finally, we walk 0, 1. Pass. Now we get 0, 2. No, 0, 0. Okay, 1, 1. Minus 1. It's all wrong. So this one is not okay. So this 0 is not okay. We were going to walk to 0, minus 1. Not okay. So yeah, down, up. It's not all. it's all not okay. And then we walk 0, 1, pass. Ah, and when I'm doing the walk, I should revert it, right? Yeah, if walk, return true. If not, we should say is used. Wait a minute. If when we return false, it's already reverted. Hmm? I'll log the is used. So when we go into here, okay. Now we is not used. Walk 0, 1. They're both not used. And the target and the current. The target should be target pop. Okay, the target is this, current is this. When we walk to the next one, the target and the shit, it should be current. I know what is going on here. Okay, we remove the console log and run it again. Okay, so let's submit. Cool, we're accepted, and yeah, it's not that fast, but I think it's acceptable, and the solution would be easy to understand and yeah, pretty straightforward as a backtracking. Backtracking space. We use two-dimensional array to keep the track of the whether the cell is used or not, and then we use two array to keep the target and the current, and we will walk. There will be a call stack. Maybe the deepest one would be m times n2. The time, it depends on what we are searching. So it's kind of, it's hard to say what the time is, but it may be, the worst case is that, the worst case is that it will search for every possible substring, but nothing is found. Just the last element would not be true. Like all worst would be all A except last one, but search for all A. Right? For this case, what time is it? It will go, okay, like go here, 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 here. This is so here, 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 here. It's kind of a permutation of a, let's say a the worst case would be it's I don't know, actually too hard. I will give up here. I don't want, it's out of my range. Okay, so that's all for this problem. Hope it helps. It's a typical backtracking problem. See you next time. Bye bye.